7 from book Applied Thermodynamics में cantilever stove. Here is the statement. In a reciprocating compressor of a refrigeration plant, the refrigerant is dry saturated at 2.01 bar at the beginning of the compression. It means it's a state point P1 and is compressed reversibly according to polytropic law. PV to the power 1.1 is equal to constant to a pressures of 10 bar. Calculate the change of specific entropy during the process using the table properties of the refrigerant given in the table 4.1 and plotting where necessary. So this is the table 4.1. I extracted from the book and shown on the screen. Where the pressure P1 that is given is P1 2.01 bar. And the pressure P2 that is given 10 bar. Both the pressure P1 and P2 in this table is given. Now first we discussed the state point P1. For the state point P1 in the statement it says it is at the beginning of the compression, it is at the saturated, the refrigerant is a dry saturated at the beginning of the compression. So it means that if I draw the TH diagram, this is the pressure P1 line that is equal to 2.01 bar, and this is the high pressure line that is P2 that is equal to 10 bar. So at the beginning of the compressions, when the compression is just begin, the state point P1 lies in the saturated, this dry saturated line. So our state point lies in the dry saturated regions. Entropy will be Sg1 and that will be equal to S1. So at the pressure 2.10 bar from the saturated values, the Sg1 value is 1.7189. So the S1 value that is equal to Sg1 and that is equal to, you can see from the steam table, that is 1.7189 kilojoule per kg. Now the state point P2 is obvious that is in the superheated values. So our state point 2 will be here on at the, now our state point P2 lies in the superheated regions. So our entropy, because it is not isentropic compression, so the entropy at S1 will not be equal to S2. So there will be a slight increase in entropy will take place. Okay, this is 2. So that increase and the entropy at the corresponding state 2 will be S2. So it means there is S1, this is the S1 entropy, this is the S2 entropy. So it means the entropy at the final stage will increase when compression takes place according to polytropic law. PV 1.1 is equal to constant. Now the volume, specific volume, that will be equal to Vg1, that is from the saturated value, you can see that is 0.0978. 0.0978. Now the entropy at the state point 1 has been calculated. Next we need to find the entropy at the state point 2. Before coming to the state point 2, there must be two independent property you familiar with in order to find the other thermodynamics properties. So the pressure P2, one independent property is known, that is 10 bar. The next independent property you need to calculate, and that we can easily calculate from this formula, PV 1.1 is equal to constant to find its specific volume V2. How to calculate? Let me take its expression from these polytropic equations. So we can write that P1 V1 is equal to P2 V2 to the exponent 1.1. If I simplified it from V2, so this V2 by V1 become 1 whole 1.1, and that is equal to P1 divided by P2. Upon further simplifications, you can get that V2 is equal to V1 multiplied by P1 divided by P2 into 1 by 1.1 to the exponent. Now just enter the corresponding values and you will get the V2 value, that is V2. What is V1? That is 0.0978 meter cube per kg. It's a specific volume, remember. Don't forget to write the units. 0.0978 multiplied by P1, that is 10 bar 1 or 1.1. So after simplifications you will get that V2, this is the V2 value that we need, that was our requirement in order to find the entropy S2 at the state point 2. So entropy at the first stage has been determined earlier. Now at state point 2 we have pressure P2, that is 10 bar, and specific volume, that is 0.0228 meter cube per kg. So we have two independent properties. On the basis of that we can conclude that the state point 2 is lie in the superheated region. So at a 10 bar the corresponding V2 value is not available. So you can see that the corresponding V2 value is not available. For that we could find the entropy. So if the value that is not available in the steam table, we will use the interpolating formula. So to find the entropy at the state point 2 we need the interpolating formula, that is equal to SA plus now what will be the value of V2 that is determined, what will be the value of VA, VB, VA, SA, SB, and similarly SA. Let me come to this steam table. I will point out each value on it. VA value, this is VB value. Similarly, this is entropy SA value, this is entropy SB value. So just get these values from the steam table and put in the corresponding interpolating formula, you will get the S2 value. So S2 okay, all the value that is needed for this interpolating formula I take it from the steam table, and here I write it for the sake of simplicity so that you can easily judge. Just now put these values that we got from the steam table in this interpolating formula. What is SA? That is 1. After simplifications you will get the S2 value, that is equal to 1.7718. so what was S1 value that was previously determined? You can check so the S2 value 1.7718 minus S1 value, that is 1.7189. so after simplifications you will see that the change in entropy you will get, that is equal to 0.0529 kilojoule per kg Kelvin.